Welcome everybody, and thanks for joining us for another session of Data Platform Downunder. On behalf of myself and Martin Catherall hosting this session, we'd like to introduce to you Yuri Barash and Mini Walia, who are going to be talking to us about big data analytics using Azure Data Explorer. Now, before I hand over to them, like most of us know, we do a little bit of a housekeeping. If you've got any questions throughout this session, feel free to put them in the chat window. Martin and I will be watching those, or put your hand up if you would like to ask a question, and feel free, we can then at an appropriate time let you ask those questions just like you would in a in-person user group. For those of you who may not be aware, just as another learning opportunity for you all, but SQL Bits is on in March 8th to the 12th. It's in London. I know it's a bit late for you to try and get your travels to head from here to London, and it's a long way, but it is a hybrid event. So just like past Data Community Summit was last year in November, this is a hybrid event as well, and you can register to go to. They have, I think, two full days of pre-conferences that you're able to sign up for, as well as all of the regular sessions throughout the rest of the week. The registration URL is here. If you would like, I will actually put this into the chat window for anybody who is wishing to register for SQL Bits for next month. So with that, we'll hand over to Yuri and Mini for today's session.
Thank you so much, Warwick, and it's a pleasure to be here. My name is Uri Barash, and I lead the product management team for Azure Data Explorer Custo. I'll tell you a little bit more about the source of the name and what it is about. But first, I'd like to introduce Mini, so go for it.
Hi, everyone. Thanks, Warwick and Marty, for organizing this session, for having us here. My name is Mini Walia. I'm a program manager on Azure Data Explorer product group team based in Sydney. And I'm part of Uri's team, looking forward for an interactive session with all of you. Thank you.
Awesome. In addition, we also have Michal with us. Michal.
Hi, everyone. Good afternoon. I'm Michal, also a program manager on Uri's team, mainly working on user experience across our tools. I'm also point of contact for everything MVP, most valuable partners or professionals. So if any of you are in that category and are being awarded for your efforts around evangelizing Microsoft products, and you'd like to do more for Azure Data Explorer, I'm sure you will after this presentation, then please keep in touch, and let's see how we can help you with that as well.
Awesome. Thanks, Michal. And let's jump right in. If you have any questions, or, this is not a TV show, please do chime in either in the chat or in voice. Let's interact. Okay, so the first thing is that we're seeing a huge increase in the amount of data that we are collecting. There are more and more devices getting connected. There are more and more types of application and instrumentation that's going on. Every organization is trying to optimize how they are operating by sensing everything that's happening around it, and we are seeing really staggering numbers of 50 billion devices by the end of the decade, and incredible amounts of data that is being collected and analyzed. this is a huge opportunity. It's a huge opportunity for us in order to be more efficient in how we're doing. We're using this information in order to become more efficient. So it does take some energy to analyze this data, but the return is that we actually get to optimize our operation in the real world, which is even more efficient. In order to take advantage of this information, there are pretty interesting, unique aspects of how we leverage it. First, we need to understand that the velocity of the business environment is has dramatically increased, and more decisions and questions are arriving at a higher pace. And this is what differentiate between a cloud native and the largest companies that we know today, and the rest of the industry that is working to get to the same level of sensing and listening. And that capability to really understand like all aspects of an organization or a system's activity and leverage it to make it better is something that is driving this type of analytics. Another thing that's happening is that changing vendors, changing devices, changing device version, new application versions, everything is changing around us in terms of the data that we collect. We're seeing new versions of the data on a daily basis. We're seeing new sources of data on a daily basis, and we need to be able to analyze that stream of very quickly changing data domain. And what we are seeing is that the way that people are dealing with this is by leveraging a lot of text and JSON as a way to collect this data without the need to change the data collection pipelines constantly. In addition, we've been trained, our generation has been trained to expect real-time visibility and response on data. And the fact that someone can like something in Facebook and immediately all his friends across the world know about it is something that has changed over the last 20 years, and this is now the standard. So when something happens, we expect to know about it immediately. One example that we've ran is that last year, the Super Bowl was last week, but last year we've done the Super Bowl together with CBS Interactive. CBS streamed the Super Bowl to 6 million subscribers in the midst of the COVID-19 pandemic. And they wanted to make sure that every one of those subscribers receives the best quality that they've paid for and the best viewing experience. So what they did is they actually looked at every single video packet that was transmitted on IP network from when it was sent to when it was received and when it was played. So the you can actually sense stuttering in each one of those subscribers in real time. They actually made routing decisions and started shifting the video streams from one provider to the other provider during the game. We've used about like 700 servers in order to ingest that amount of real-time data and make real-time decisions on that. But the game went flawlessly, and this is what we call real-time decision-making based on analytics. Another thing is that many times this type of information is very verbose, very large volume, and analyzing it and extracting value out of it may be expensive if it's not done efficiently. When we've first met Tabula is one of the largest content recommendation firms in the internet. They used both a Google BigQuery and Elasticsearch in order to analyze the user experience log and activity records. And they were on the verge of scaling down their collection to just collect a small sample of that activity data. It would still help them understand if their service is operating successfully in the different regions, but they wouldn't be able to troubleshoot and understand what a single person has experienced. We worked together and we managed to reduce the cost for their analytics that enabled them to continue and look at the entire set of data, which was super significant for them. For them as well, if someone is not getting the recommended content, they immediately lose money. So this is like really about like operating their business effectively. And the last interesting point is that when we're doing observational analytics on activity, log activity, metrics activity, any kind of other activity, we're actually looking for the unpredictable. We're looking for the hacker and their attacks. We're looking for malfunctions that are also unpredictable in nature, for user trends and their unpredictable behavior, understanding ways where it's coming from. Market trends in spot markets, every kind of operations and activity that we would like to analyze in that sense. One additional story around that is that we've done a workshop with Grab Taxi, and they are one of our massive customers these days, customers and partners. And what they told us is that they've seen a phenomena. We actually managed to detect this in the workshop within a 2-day period. They saw like cab drivers arriving at an airport. Everyone turns off their app in a coordinated fashion. Supply goes down, demand goes up, prices goes up, and then everyone like turns on their app in the same times and go home happy ever after. Now, this type of an inventory attack is something that you could not have played for. And the ability to analyze raw data allows you to look at data in unique and different ways every day and practically support the need for being able to answer in data-driven manner the new business questions that are arriving at a higher pace on a daily basis. So what is Azure Data Explorer? So first, I'll use the name Kusto and Azure Data Explorer interchangeably. We call this technology Kusto, inspired by Jacques-Yves Cousteau, who invented the scuba diving. As a paraphrase of like diving the ocean of information. And so what is Azure Data Explorer? It's a near real-time analytics database that is optimized for observational data in petabyte scale. It's a complete analytical and query engine. From the ground up, it's built fresh on top of compute and storage. I'll talk about how it fits into Synapse in a second. It's optimized for this data specifically, timestamp data, logs, time series, telemetry, practically every type of raw activity data that we collect. It naturally supports full text and JSON. As I explained, this is this is where the growth of data is happening. And it supports low latency for near real-time data analytics at scale, both the ability to ingest like massive amounts of data and make it available for query in short time, but also the ability to allow humans to interact with the data in very, very low latency. Let me show you a very quick example. I'll start with this one. This is a small table. Come on. It's connecting now. Network is fine. So this is a small table. It has like 1, 2, 3, 4 commas. So 46 trillion rows. We are now looking at how data is arriving into that table. And we can see that 15 minutes ago, we've seen about like 1.1 billion records landing in this table every minute. And our development team, our operations team is using this table in order to analyze how our service is operating, and they're doing it on a all the time, practically querying these tables and understanding like how our service is operating. And this gives you a hint on the scale, and we'll talk about numbers in a second. Let's look at this, for example. This is activity registered by the GitHub service. It recorded every activity that happened between users and GitHub over a period of 3 years between 2016 2019. And we have about like 1.2 billion records in this table. I'll just remind you that in the previous table, we had 1.2 billion records ingested every minute. In this table, we can actually look and see if the data is complete. And as you can see, we now aggregated the activity between users and GitHub by bins of 1 day. And we scanned those 3 years, and you can see that the data is pretty complete. You can see the weekends. You can see the holiday seasons for 2016, 17, and 18. And by the way, all the queries that I'm going to run today are actually recomputed as I run them. We are not caching the query results because we're looking for fresh, unique queries that are being run by individual users. And if we're looking here at the data, then you can see that this data is even pretty complex. Some records are fairly simple, but some columns are pretty complex. Every row can practically have its own schema using a dynamic JSON field. We can query into that JSON field to generate a calculated column. The actor display login is the unique identifier for a person in the GitHub logs. And what we can also do is we can ask like how many unique users, distinct count of unique users have we seen between 2016 and 2019. And we'll run this by practically opening up 1.2 billion JSON records and compute that 16 million unique people unique persons have interacted with GitHub during this period. And that query ran for 4 seconds. So this is what we mean by interactivity and user scalability. So what is Azure Data Explorer? It's a data platform for big data, append-only a stream of records, and high volume, high velocity, and high variance. You've seen the volume, velocity. We can ingest around like 200 megabytes per second for every node that's deployed in the backend. Our largest table ingests about like 300 terabytes per day. And it's optimized for semi-structured text, free text. It supports a relational model with columns and rows and tables, and just like any other data platform, and filtering, aggregation, joining, calculated columns, all that, but also full text search and indexing from the get-go for all columns, and the ability to run time series analysis natively, the ability to run Python and R inline, sending the Python and R code into the data rather than moving the data, which is big, to where the code runs. And it's fully managed on Azure with no specific domain in mind. It's optimized exactly for this purpose. It was built for this purpose, as opposed to other platforms. For example, Elasticsearch was built in a search engine for a website. and you can see the difference in efficiency, and it's built for interactivity, as you've seen. A little bit about numbers. Now we are ingesting more than 85 petabytes of data per day. We're running like over 1.3 billion queries per day. And by the way, this slide gets stale very quickly because over the last 6 months, it grew more than 50%. And 6.6 exabytes of data available for query at every given moment. It's pretty massive. And one thing that you may or may not know, like we have like over 300,000 KQL users. KQL is the custom query language, is the language that I showed that we're using to run queries against the Azure Data Explorer custom. For us, it was the key for the digital transformation. Microsoft, when it started using Azure Data Explorer, it started by a few folks internally that were moving Power BI from being a desktop application to the cloud, and they needed a way to understand how that new service is operating in the cloud. That they created a repository for logs and activity that was quickly adopted by every other Microsoft service, replacing Splunk in Windows and Office, saving about like 70% of the hardware cost, not the licensing cost. And then it was adopted by all other Microsoft Online properties. So even the data platform, SQL Server and Cosmos DB and all the other ones are using this for analyzing their telemetry. And then we replace the underlying platforms for all our analytical solutions as a service. So all our monitoring solutions or our security products or IoT products are using Azure Data Explorer as the data platform for serving insights and analytics, also gaming analytics, team education analytics, cost analytics, and more. And 2019, we released it as generally available for our best partners and customers. 2021, we've introduced it as part of the main brand for analytics, which is Synapse. I'll talk about it in a second. So another short demo, I'll try to run through this very, very quickly. So in this case, we're looking at a database with 30 terabytes of data. We have two tables here. One is like alerts and one is time series. In the alerts table, that is about 25 terabytes of data. We have 41 billion rows. We'll do a dashboard classic query. We'll take those rows, we'll aggregate them by, we'll slice them for 1 day and aggregate them by the error level of those logs. And you can see that this query that runs over 800 million rows in a 41 billion rows table finishes in less than a second. You can see that the red rows here are alerts, are errors. Just checking if I have any, like, there are like 2.5 million errors in this data set, and we'll do a short exercise of figuring out where they're coming from. There is this is the data. You can see it's structured columns, rows, etc. Low cardinality strings, high cardinality strings, date and times, integers, doubles, and also full text blobs all get indexed automatically as the data comes in. We'll do we'll try to see if there is one specific type of machine that is generating more errors than the others. So we'll look at the role field. And in the role field, you can see that the developer put both the machine type and the machine index in this column. So what we'll do, we'll parse the role field into the role type column. And then we'll bin it by bins of 10 minutes and render a time chart. And we can see that one type of machine, the SharePoint integration role, SPI, you see we generated a calculated column, is generating more errors than the others. So this is actually, by the way, real data coming from the Power BI machines that are running the Power BI service on the Microsoft domain. Another thing that you can see is like we'd like to see if there is one user who suffered more than others from these errors. So what we'll do, we'll search using full text search. We'll search for for events that are login by identifying this pattern, extract the stable user ID, associate the user ID, stable user ID with the session ID, and then join it back to the errors in this table. And this is a 20,000 login events joined with a 2.5 million errors in a 41 billion rows table, and it finishes in, again, less than a second. You can see that 3309 is a poor soul who suffered like almost 2,000 errors in this duration. And what we can do now is we can actually drill down and see what this person did, what did they experience by extracting the exception code from the text. Everything here is running on a single table. No result is actually cached. And we can go and investigate this incident all the way and see what happened before, during, and after. And what's fun about this type of system is you can run dashboards, investigations, and alerts on the same data and not hopping between systems, which creates a lot of inconsistency. Now, this query language is called Cousteau query language. We are getting a lot of very positive feedback. All our security products are exposing it. All our operational products are exposing it. As I said, we have like almost over like 350,000 users that are using it on a regular basis. But we know that SQL is actually a pretty useful language. A little bit old, but still very, very prevalent and useful. So in case where people want to convert SQL queries to KQL, we have an operator that allows them to take a SQL query and translate it to KQL. As you can see, it's usually shorter. And when we ran large scale conversion projects, usually the queries shrink to about a third of the size and become a lot more readable. But sometimes there are tools that are already pre-built and compiled that are out there that need to work, that know how to speak SQL. So we actually run SQL statements. We actually provide a TDS endpoint, which is the on-the-wire protocol for SQL Server and the Synapse data warehouse, so that this is the same protocol, the same binary protocol on the wire. So if you have an ODBC, JDBC, you can actually point it to Azure Data Explorer and it will continue to run because it behaves like a read-only SQL Server. Another example is like now we're looking at like 30,000 different time series in a 35 billion measurement table, and we're looking at the 3 machines that reach the highest CPU. See, we're looking for a top 3 by max CPU, and yeah, we can see that like there are 3 machines here. One rebooted, we found it out after investigating it, but 2 are kind of leaking CPU. So what we'll do is we'll try to see if there are more machines that are doing this kind of like CPU leakage. We'll do it by doing shape detection. We're looking for jump shape in the CPU time series for those 100 machines that are emitting time series data. And what you can see is that there are more machines that are leaking CPU. You can even see exactly the date when we deployed the bug that caused them to leak CPU. Now those queries, they run like in few seconds, analyzing 30,000 different time series in parallel. We also have the ability to do automatic clustering, for example, like tell us what is the main cause for the 2.5 million errors that we've seen in these logs. And the answer is using auto clusters, then we can see that like 42% of the errors are actually a result of SPI role number 4 machine that is having problems. Switch back to the deck. So the news is that we've late last year we've included Azure Data Explorer as an inherent part of Synapse. So now, in order to harness that opportunity of like telemetry data and observational analytics on top of it, and we've added Data Explorer in addition to the SQL and Spark engines, and the second.
Just one point quickly.
Sure.
Do you plan to cover the slide which talks about the overlap, or I would say the when to use ADX versus data warehouse? Somebody asked the same question. I know you have awesome slides, so.
Yes, I'm getting right into it. So I'll skip the architecture for now, and I'll go back to it in a second. Okay. So first, let's talk a little bit about databases. This is actually something that we copied from a Gartner report, but there are two main types of databases. One is OLTP, online transaction processing, and here we find SQL and all the open source SQLs. And also NoSQL databases that are used for applications to store and read in low latency and sometimes with transactions, operational data that that they need in order to work. And there are OLAP, online analytical databases. And here, when Gartner wrote this report, we've had Azure Data Explorer for non-curated data, and I'll explain what it is. And Synapse Analytics, which was the rename of our data warehouse for curated data marts. What we've done is we've actually merged them into Azure Synapse Analytics, and now Azure Synapse Analytics is capable of handling both these workloads, but also the Spark workloads and ETL and etc. So when we're talking about cloud scale analytics, we're talking really about like 3 patterns. One is the modern data warehousing. I'll give an example of what it does. Another one is machine learning and real-time analytics. The Azure Data Explorer Custode technology is for the real-time analytics. Again, I'll drill into this. We started with Synapse by rebranding the modern data warehouse. We've added Spark, and now we are covering the full spectrum also with real-time analytics. When we're looking at the data warehouse pattern, usually we started by creating a well-curated data marts with well-defined entities and attributes. And then we create a nice ETL that takes data from a variety of sources and creates that well-curated data mart with objects and entities and attributes, and then loads them into a SQL data warehouse and then serves them with Power BI. What you get here is that all the elements of the data are well described, well documented. They are very consistent, and every usage of them, whether it's in Power BI, where every user in the org can actually create their own report on that data, and applications are treating that information in a very consistent and very well managed way. That has a lot of value. The disadvantages is that usually it requires a nightly ETL or like few hours ETL, so you usually don't do real time this way. And it provides you a one way to look at the data, which does not address the needs for security and fraud and the other things that are unpredictable, and you do need to investigate them using the real activity and allow you to count things differently every time. And this is where the real-time analytics patterns comes in. Data is arriving usually in real time, in streaming from a variety of places. You can also route it in batch, but you are capable of getting data in minutes and seconds latency, you can analyze it using Stream Analytics for real time, like sub-second response for events, and small window counting, like 5 events of this type that happened in the last second. Or you can push them into Azure Data Explorer, where you can compare like the current activity against the previous week or previous month's activity. Look at what happened in the recent seconds, days, weeks, and months. Depends on how much resource that you apply to the workload. And those scenarios are very, very different. So in this case, if you look at this diagram, you have on the left side analyzing raw data, on the right side analyzing the well-curated, pre-processed data marts. On the top, you have the interactive queries where human interact with the data, ask different questions every second. And on the bottom, you have the batch long-running things that you typically do with Spark. So when we're referring to those patterns, then the data warehousing pattern is where you prepare and serve well-curated, pre-processed data models with referential integrity and transaction, classic data warehousing. In this area, you are doing machine learning. You are running batch jobs over large quantities of data, and you generate models, and then you can evaluate those models and operate them. And the observational analytics, the real-time pattern, allows you to run those analytics on raw data and leverage some ETL and machine learning, usually done by Spark, in order to build models that can be analyzed by users interactively. So I hope that addresses the question. I'll go quickly back to the architecture just for a brief. And here you can see a little bit, just in a very briefly, data coming in from a variety of sources, streaming, but also the lake, listening to the lake, APIs, Data Factory, Spark. The data arrives and is, as it comes in, it gets indexed, compressed, and stored both on the local SSD of the machines that are running the backend of the service and in blob storage for persistency. And when a query comes in via REST API, Power BI, direct query, or get data, the UI that I showed you, but a lot of other other tools, including TDS endpoint, ODBC, JDBC, and open source technologies. A query comes in, it gets distributed between the different nodes in the backend of the service that holds the data, and then the result getting aggregated and returned to the caller. We also know how to federate queries, both to the data that lives here in the ingested data and the SSD, but also to the data lake, to SQL Server, to Cosmos DB, to Azure Monitor and Sentinel, to Azure Data, Azure Digital Twins, etc. The one thing that this architecture delivers is, first, there is a separation between compute and storage. You can pause the service, you can resume it, you can have multiple compute engines working against the same ingested data. And the other thing is that as data comes in, you can actually write it into the data lake in a nice Parquet lake formation with year, month, day, etc. You can also export it to SQL on an ongoing basis, and that creates a pretty complete data platform. With Spark, we have a very cool scenario that is being adopted by our largest customers they are running Spark over data inside Azure Data Explorer, pushing down the predicates and featureization, only getting the features back, training the model, and then uploading the model back into Azure Data Explorer. And then they use this model in order to score, detect, and reach data that's streaming in from IoT hubs, Event Hub, etc. So to summarize a little bit on the architecture, it combines metrics, time series, text search and analytics, including multidimensional analysis with joins, etc. Using a intuitive modern query language that supports IntelliSense and lends itself to people interacting with data, but also fully extensible with Python and R to run practically every algorithm that you want to. High performance over a large scale ingestion and in low latency. And another small demo that I want to show you is the cost demo. The cost estimates that we use for Azure Data Explorer is practically a type of cost plus. So so this is actually available from our Azure. Okay, I'll skip this for now, and when Excel wakes up, we'll go back to it. Minnie, are there any other questions that we want to address now?
Sorry, Uri, I was on mute. No, I don't see any other questions on the chat. Maybe if anyone wants to ask anything. Warwick, can folks unmute themselves and ask questions?
They should be able to.
Okay, cool. Okay, there's another question from Anil. Can we use KQL in direct query of Power BI?
Definitely. Yes, this is necessary in order to run big data, because the big data won't fit into the Power BI memory location. And this is why we use direct query very often. We are working very closely with the Power BI team on continuing to improve that capability, including the new addition of like allowing dynamic parameters in M, so you can actually push down parameters directly into the underlying storage engine, in this case Azure Data Explorer, in order to optimize the query in advance rather than generate all the data and only filter it in the last phase using a where clause that's being added by the Power BI model. The service is progressing very, very quickly. I won't go into every aspect here, but we've practically rewritten it from scratch over the last 3 years, and we rolled out Engine v3. It produced between like 2 times faster and 100 times faster, depends on the queries. So we are constantly investing in this technology and making it better and better. Our data management capabilities, including materialized views, partitioning, support for Parquet constantly improves. And there are more things like geospatial, etc., that are making a lot of progress. I want to show you like a few exciting things. So first, I'll hand off to Minnie for an overview of like how to do SQL monitoring. So go for it, Minnie, and then we'll switch to another like super exciting things, and we can talk about scenarios, customers, etc.
Sure, thanks, Uri. That was wonderful. And 1 second, I'm just sharing my screen. Give me a second. Okay. Can you all see my screen?
Yes.
Yes, we can.
Yep,
Minnie.
sure can.
Cool. So I'll just, I won't take much time, very quickly. I just wanted to talk about one of the use case, which is relevant for the SQL experts, monitoring of the large SQL ecosystems in the cost-effective way with low latency and with the comprehensive, rich data sets. I know SQL monitoring is not so easy today. So we released recently a new output plugin for Telegraph. I'll talk about what exactly the Telegraph is, if in case you all don't know about it. So this new plugin, just a bit of a background on that plugin, why we invested in that. A lot of large SQL customers with 50K plus 50,000 plus databases, they had been either using Azure Data Explorer for different types of logs and metrics and wanted to even collect SQL metrics over there, or they were using Telegraph already to collect the metrics. And they requested, can we have a direct route to pump data into ADX rather than doing all the workarounds? So that's why we invested in this one. And by far, as far as I know, Telegraph SQL plugin based monitoring solution that uses dynamic management views under the hood is the best and most cost effective solution so far. I would love to hear your feedback, knowing your expertise in the SQL area. So a bit of a brief on what exactly Telegraph is. Telegraph is an open source lightweight agent, which is used primarily to collect and send telemetry data. And when I say telemetry data, it could be logs, metrics, or any type of time series data. And Telegraph has got hundreds of input and output plugins. It's mainly written in Go language, so quite lightweight, as you can imagine, and it compiles as a single binary. The best part about Telegraph-based solution is it's completely configuration-based. And to get started, what you need is just one binary file and a config file. In the config file, you configure your input and output plugin configurations. That's it. You're good to go. I'll show you that quickly in form of a demo. And Telegraph can be deployed either on VMs or on containerized environment. It does provide even the Helm packages for the Kubernetes environment. So with Helm package, it becomes just a single line of deployment, essentially. And it is very well integrated with the rest of the time series analytics ecosystem, be it streaming data using different types of sources or monitoring platforms. So that's where now we have ADX also in that family. Okay, so very quickly, how Telegraph plugin has solved the problem for those large SQL customers. The below pipeline is what, based on my discussions with the customers, what they were using. So as you can see, customers were using Telegraph Prometheus plugin to collect the data from SQL servers on premises or different flavors of SQL on Azure, be it SQL DB, MI, or Elastic Pools. And they used to route the data via Prometheus or used to use diagnostics logs, route to Event Hub, and then to ADX. So this solution used to add a lot of complexity, latency, and other issues. In fact, if you compare what data is being collected via diagnostics logs, is not even as rich as what is being collected by the Telegraph's SQL input plugin. So SQL engineering team has invested quite a lot in that SQL input plugin, which uses all relevant DMVs to collect the data, and that's where the richness comes from. So now with the newly introduced ADX plugin, as you can see, it simplifies the pipeline. So you just need one Telegraph configuration for SQL input and ADX output plugin, and there you go. So it basically reduces the cost and complexity of maintaining all these different components. And you can have low latency, there are no multiple hops, and you get richness of data because it collects quite comprehensive data. So you get the insights around the transactions per second, user connections, CPU, memory, and all the stuff around SQL ecosystem. And of course, you get the direct ingestion path to the platform, which was purpose-built for these sort of scenarios. This is pretty much, I just wanted to talk about the Telegraph plugin. Let me know if you have any questions so far. Otherwise, I'll show you very quickly how easy it is to use this plugin.
So, Minnie, just one question for you. Now, I
Yeah.
know there's people out there that use, so with using, you know, either Influx or Prometheus for the storage, and then people would be using the likes of Grafana to have the graphical output and displays for what they're collecting. Is there any interaction or thoughts about interacting with Grafana into the mix?
Great question. Yes, Adx has a native, very well integrated Grafana plugin. So you can very easily connect to the Grafana dashboards and build those dashboards just like you will do with, for example, using InfluxDB you mentioned as a database or any other database. And in fact, the best part is with the Grafana, we have got a lot of optimizations which are baked at the data source level. So for example, the consistency, the strong or weak consistency, if you want to configure query level caching, a lot of other optimizations for building high concurrency dashboards, they are there. And in fact, also we have the KQL query builder support with Grafana. So yes, absolutely. If you are using SQL input plugin, ADX output plugin to ingest into ADX, then you can use either ADX dashboards or Grafana or Power BI, any of the visualization tools of your choice to build those SQL monitoring dashboards.
Excellent, thank you.
Awesome. Any other question? I saw somebody else was about to. Okay. Okay, so I'll move on. I'll just talk about how you can, you know, how easy it is to get started. So basically what you need to do is you just go to the Influx data and get your Telegraph release. And the Telegraph release, you select your Telegraph version and it has the different platforms supported. So just for the demo purpose, it's easy to show on Windows. So use your platform, you run your wget command either on Windows or Linux, and you get your Telegraph binary and config downloaded onto the specified folder. So for example, here I have got these two files, the binary and the config file, into this release folder. 1.21 is the latest one. And very quickly, I'll show you how the config looks like. This is the Telegraph config, super easy to use, wherein the first part talks about the Telegraph agent configurations. I won't go into the detail of it. It's all given in the documentation, but the most important ones are how you configure your collection interval. So for example, I've given 20 seconds. You can even go down to 10 seconds as well. Some of the customers, they tested with that. And you define your metric batch size. And if in case something goes wrong, Telegraph also provides the buffer limits. So it can store the data onto the memory of the VM or container. If at all something goes wrong, ideally we should try to set the configurations in a way so that your flush interval is able to flush the data as it collects. So I'm collecting data at 20 seconds and flushing at 10 seconds just to make sure if something goes wrong, it flushes again, and we are not, you know, putting strain on the memory of the system. So that's pretty much. And here in the configuration, I've set debug true just to show you how it starts kicking in the data. And you can also get the logs in form of files, just uncomment whatever you need. So here is the ADX output plugin configuration. Super easy. You give your ADX cluster URL, database where you would want to ingest the data, and your table name. So these three things are what you need to do. Otherwise, rest all the default configurations will work. And you can say some of the customers, for example, said we don't want to create new tables, we just want to use the existing ones. So that is also configurable. And if you have not used the SQL input plugin, that is also very easy. Here you can just define your SQL Server connection strings and the database type. So for demo purposes, I'm going to use the Azure SQL DB. You can use any MI, Elastic Pool, or SQL servers. So that's it. So you define these configurations and you're good to go. Here I'll show you that I'm going to run it in the debug mode just to show you how it kicks in. So same experience you get at the Linux as well. So once you start, it just starts writing the matrix to the ADX table, what I defined in the config. That's it. That's, you see, it has just started. Then you can just go to the ADX table and start seeing the data flowing in. So it has skipped the table creation because I defined create tables as false, and it wrote 1319.8 matrix in 1.4 seconds. So this is all based on your configurations. Just one thing I want to touch on here as part of this. So for example, at the ADX side also, you can configure your ingestion batching policy for your table or database level. I modified the batching policy at the table level to 20 seconds. So there are 3 key configurations wherein either the time or the number of items or the size of the data, whichever hits first, it triggers ingestion. I wanted to ingest at 20 seconds interval, so that's what it is. And I'll show you very quickly then one of the sample dashboard which I've created using Adx Dashboard. Now creation of the Adx dashboards is pretty easy, and same way you can use, as I mentioned, any of the other visualization tools. So for example, okay, let me just go back on the same SQL matrix. This is one of the ADX dashboard I have created on top of these SQL matrix. So this is what it looks like, where you can monitor your CPU usage and the transactions per second, all the file stats and everything, and you can easily edit this dashboard. So for example, you go here, change your query visualizations, or you can just drag and drop all these tiles. Sorry. You can drag drop these tiles, or you can just simply resize them pretty much, and you can parameterize your dashboard also. Let me discard this. I don't want it to be disrupted. So for example, here I've done the parameterization. You can parameterize based on the timestamp or any of the columns. For example, this dashboard, I'm collecting data from 10 different SQL servers on-prem. And let's say if I want to just see the data for SQL Server 8, I can just search across that, and you see my dashboard, it gives me the data for this SQL Server 8. That's pretty much a quick look at how you can build very easily the ADX dashboards with parameterization, searching across things. Any questions on this?
Mini, that's super cool. I'll just throwing the last boon for this now, because one thing that we are making available, which makes it even more interesting. Other than all the things that are coming, like Synapse link to Cosmos DB and Custo as an emulator for CI/CD and unit tests, and more in advancement in dashboards, we are adding serverless personal clusters that are free. Let me show you. Like, you can go here, go to this like new tab here. Oh, I already have one. I'll delete it. no worries. Let's assume that I don't have one. Go away. Yeah, so let's assume that I don't have one. And I want to create a new cluster. Everyone using an identity, Microsoft Identity MSA account or AD account can create one. It's automatically resumes and pauses so that we don't like burn too many trees. And you can actually go and create one. Sorry. You can go and create one. It takes a few seconds only, and you get your own personal cluster that you can do SQL monitoring to. And it's completely free. It comes with, while it gets created, I'll show like some stats. It comes with 4 cores, 8 GB of memory, and about like 100 GB of data that you can store there. It's a free trial for 1 year and very likely will be renewed on a yearly basis. And going back here, we have the cluster here. We can go and ingest data into here. Second, it's DSV. Yeah, I don't know what's it doesn't like me today, but I'll just go in. Or probably it's a mel file. So I ingested this. It didn't work as CSV because the file is not a full CSV, but I ingested it as rows so I can analyze it, and I can go ahead and query it. So I created a new cluster. I ingested data into it. I created a table, and then I can just go ahead and run it, and here is the data. So gives you an example of how quickly and how massive this can be. You can go and use it yourself. This is the link. This is the QR code. And please do send us feedback. We're super interested in getting your feedback on this. We are launching it practically tomorrow. So it's a sneak peek for you guys, and definitely looking forward to hear your feedback and everything that you can do with it. Load your bank statement, your phone call logs. It's already being connected to Home Assist, which is the most commonly used home automation open source system. So there are so many usages that you can do on the personal and on the business level. So let us know. With that, I think we're how much? I believe that we're out of time by now. Correct, Warwick, Minnie?
Look, we're just on. Given we started a little bit late, we're only a little bit over. If you've got more content that you wish to cover off, we can keep going for another 10-15 minutes if people wish to hang around and continue.
Yeah, sounds good. I'm been to hanging around.
Awesome. So I'll show you a few things. First, in the end, we have like 4 partners. We have the ability to join our partner network. We'll make it possible for locating partners for specific workloads very easily soon. And there is also a way to get like free POC resources for running a POC, you know, with a start and end time and the ability to and the definition of what success means. So the free cluster, the personal cluster that I showed, is good for like starting and doing like a relatively small thing. But if you need like, you know, a cluster of 100 machines in order to build a real massive proof of concept on real workload, real massive workload, then talk to us. There are quite a lot of resources in this deck, and I'll share it. And I'll go back to some customer stories if you want to hear like a little bit more. So, yeah, any questions, please chime in. Like, that's
Yeah,
awesome. So,
I think it would be great to hear from you folks too. Like, how does the, you know, whatever you have seen so far, what we represented, how does it look? Does it sound easy to get started, or anything you would you think we can provide help in terms of folks to get started, or any other feedback around the product? Okay, Peter is sharing some feedback.
that's a wonderful point. That's a wonderful point. Peter is saying like looks powerful, but maybe an intimidating learning curve. That's a good question. You know, I can tell you like we have it on video. We had a conversation. We had Eric Eric from DocuSign. He was the CTO for DocuSign, and he joined us in one of the conferences. And he said, like, you know, I spent 4 hours. I connected my telemetry workload for DocuSign into it wasn't called Azure Data Explorer back then, into Cousteau. And he said, like, in 4 hours, my entire organization changed, because now people were empowered to go and look at things. We have like online courses that within a couple of hours, you start being dangerous in your ability to look at data. And that's those free courses are both by Pluralsight and by Microsoft, and you can get yourself like ramped up in less than a day. We've had a conversation with a security firm. Now they're called Talion, but they were part of like British aerospace managed security solutions. And they told us like, you know, we can't use this because we'll have all those people that are regularly using Kibana to start like moving from Kibana to Azure Data Explorer, and we actually added Kibana support, right? We added Kibana support so you can use what we call the K2 bridge. It's the ability to connect Kibana to Cousteau. So we have Kibana running on top of Azure Data Explorer. We even added support for Kibana Dashboard and visualization recently. But what happened with Talion is that they actually provisioned this managed security service to their customers, and they provided them the Kibana. And once those folks discovered KQL and the ability to actually run queries against the raw data, they stopped using Kibana in days. And we asked them like, but don't you want to use this thing that we built for you so that you can easily migrate? They said no, they're not looking for it anymore. So we've invested in a lot of like migration and ramping up capabilities, but eventually what we found out that the power that we are providing here, and the unlimited capability to manipulate data in unique and based on the needs of the day is so powerful that people are getting addicted very quickly. I had a discussion with one with a person in Belgium who was running the IT for a small newspaper, and I gave him, you know, a free POC cluster, and after 2 days he called me and said, I can't sleep. I'm keeping like running queries and looking at what my readers are doing against data, and it's like so much fun. Like I was never able to do it before, and this is the kind of experience that we're seeing. Yes, managed security identity is supported. So, but you know, on the learning curve, we'd love to hear your feedback. We'd love to hear feedback both on the courses and on the free cluster, and the ability to start quickly, the help cluster, the documentation. If you have any ideas on how we can make it even easier, we are investing in this area. So completely. It was used to be called the best kept secret in Azure, because Azure really is built on this. Whenever we build a new region in Azure, one of the first services that is getting deployed is Cousteau, because you don't know what compute and storage and networking is doing unless you also deploy Cousteau. So it's deployed in every Azure regions, including the government clouds and the wherever Azure is present, practically.
Martin, great to see that you already spun up the health cluster. So, Uri, we can share some of the tutorials, some of the queries with them, so they can start analyzing data in a better way. Can we?
Yeah, go for it. Go for it. Yeah, by all
Sure.
means.
So I'll share, Martin, just to let you know, we are planning to release another feature wherein there will be sample queries and sample dashboards. So you get end-to-end view, the help cluster with sample data sets and some tutorials, the guided tutorials with a lot of comments for the beginners to get started, and some of the sample dashboards. So end-to-end story for the beginners to get started easily. And I would love to share it with you to get more feedback.
So yeah, I think I'll switch to this. There are a lot of links here, and a lot of ways to stay connected, including our emails. Please, like we enjoyed interaction. We learn a lot from everything that we do together. So please reach out. And thank you so much for the opportunity to meet and share.
Yeah, that was a great presentation, Yori, and many thank you very much for that.
Thanks all.
Thank you.
Yeah. So to start your day over there, is it?
Yes, it's
okay. Have a great day.
yeah, like have a wonderful evening and rest of the week, and get a free cluster and load a lot of your personal data into it and have fun. So thank you so much.
Yeah. Thank you.
Thanks all. Bye-bye.
Bye-bye.
Yeah, catch ya. See ya.